In many applications, we want to know not just the relative maximum or relative minimum, not just the biggest value in its vicinity or the smallest value in its vicinity, but we want to know the biggest value overall or the smallest value overall. This would be, we'd want to know the absolute max and minimum. Okay. There are a few, usually when we're dealing with absolute max and minimum, we're dealing with a restricted interval of the on which the function is defined. And so let's take a look at an example. There's a couple tools to help us do this. The first is the extreme value theorem. And the extreme value theorem says this: if f is continuous on an interval, on a closed interval, I should say, of finite length, we'd say closed and bounded interval. So it can't go from like 3 to infinity or negative infinity to -2. That would be of infinite length, but from, say, 3 to 5, something like that. Another way to think about it is we could draw a circle around it if it's bounded. All right, then f has both an absolute maximum and an absolute minimum on that closed interval. Now, the extreme value theorem just tells us that there is a maximum and a minimum, but it doesn't tell us how to find it. But we can find it in this way. And this is what we can say is that we have to look in three places. The first place is at the left end of the interval. Okay. The second place is at the right end of the interval. And the third place is at a critical value between the left and right endpoints and on the open interval between A and B. Let's take a look at an example of this. Let's find the maximum and minimum values of f of x is equal to 2x to the third plus 3x squared minus 12x on the closed and bounded interval from -3 to 0. Notice this is a continuous function, it's a polynomial, and this interval is closed and bounded, so the extreme value theorem says that there is a maximum value and there is a minimum value. Now, where do we find them? Well, remember the three places to look. First, look at the left end point, x is equal to -3. Next, look at the right end point, x is equal to 0. And the third one will take a little bit of work, but the third one we have to look for critical values in between -3 and 0. So to find critical values, we'll have to take a derivative. So f prime of x is equal to 6x squared plus 6x minus 12. Let me factor this. I can take out a 6, and I'll be left with x squared plus x minus 2. And this factors further as 6 times x plus 2 times x minus 1. Let me just double check that, x squared. All right, then 2x minus x is x, and -2, yes, that's right. So remember that the derivative, the critical points are where the first derivative is either undefined or 0. This is a polynomial, so it will never be undefined. So let's find where it's going to be 0. I'll set the derivative equal to 0. And if I do that, well, of course, 6 is never 0. It'll be 0 when x is equal to -2 and when x is equal to 1. So these are the places where this function will have critical values. All right, notice only one of them is on this interval. -2 is on this interval. 1 is not. 1 is to the right of this interval. So I can eliminate right away 1. I'm not interested in what's going on outside of this interval for one reason or another. So we have then finally the third one, x is equal to -2. All right, now just so I wouldn't make any computational mistakes, I think I've evaluated this in the next page here, and I've found those -2 and 1. And so notice here's the left end point. Okay, at the left end point, if I evaluate this function, the original function here at -3, I get the value of 9. Right, if I evaluate it at the right end point, I've just put these points in numerical order. The right end point, I get 0. Evaluating this at 0, it's pretty easy to see that's 0. If I evaluate it at the critical point in between, f of -2 is 20. Now if I look at these, one of these is going to have to be the minimum value, and one of these is going to have to be the maximum value. Well, of course, the maximum value will be the largest, so this will be the maximum, 20. And the minimum will be the smallest, which is 0. So this function has a maximum value of 20. All right, notice we can see that that's 20. All right, that's the maximum. And it's just produced by this value 2. Lots of times students will say 2 is the maximum, but 2 is just a value that produces the maximum. It has a minimum value at 0, and 0 is the x value that produces that minimum value. So the maximum is 20. F of negative 2 equals 20 at x equals negative 2. The minimum is f of 0 equals 0, and that occurs at x equals 0. Let's take a look at another example. Okay, let's find the maximum and minimum values of 3x to the 4th minus 20x to the 3rd plus 36x squared minus 16 on the closed interval from 1 to 4. Well, this is a continuous function because it's polynomial. Polynomials are always continuous. And so let's see, we have those 3 places to look. First one is the left end. Second one is the right end. And the third one, as we said, will take a little bit more work because that's going to be at a critical point in between. So let's take a look at this. To find a critical point, we first of all find the first derivative, and that's going to be 12x to the 3rd minus 60x squared plus 72x. This we can factor. We can take out a 12x. So if I take out a 12x, I have 12x times the quantity. X squared will be left from the first term. I have negative 5x from the second, and then I'll have a positive 6 from the third. And so let's see. So if I look at this, this is going to be 12x, it factors further, x, excuse me, minus 2 times x minus 3. Now let me just double check that. X squared, negative 2x, negative 3x is negative 5x, and then 6. So this will be the factorization. Remember that the critical value is, or critical point is where this function, the derivative is equal to 0 or undefined, and as we said, this is a polynomial, so it's never undefined. So we're left with finding out where that's 0. So I'll set that derivative equal to 0, and I get x is equal to 0, x is equal to 2, or x is equal to 3. Those 3 values make this derivative 0. And all but one of them are on our interval. We're not worried about 0 because 0 lies outside of the interval. So we have then the 2 values, x is equal to 2, x is equal to 3. I think on the next page I've evaluated all these so I didn't make a mistake. And so we have basically x is equal to 1, the left end, x is equal to 4, the right end, x is equal to 2, and 3, the critical points in between. Notice in this case the maximum, the largest value, is at the right end point, x is equal to 4. This is the maximum. The minimum is at the left end. X is equal to 3. All right, and let's see if we look at this. Here are the 2 endpoints. Notice x is equal to 4. We get 48. I'll excuse my artwork. At x is equal to 4. And at this end, x is equal to 3. This one's at a height of 16 and at a height of 11. But those are values in between. So the maximum I think I'll just state this without stating its function. The function is 48 at x equals 4. The minimum is 3 at x equals 1. And that's how we use the extreme value theorem to find maximum and minimum values.